Okay, let us solve the second problem under reservoir problems topic. So your three reservoirs A, B, and C are connected respectively with pipes 1, 2, and 3, joining at the common junction P, whose elevation is 366 meters. Reservoir A is at elevation 933 meters, and Reservoir B is at elevation 844 meters. The properties of each pipe are as follows. So, nandiyan na. Alam sa akin, dami. A pressure gauge at the junction P reads for 1,950 kilopascals. What is the flow in pipe 3? Flow, flow in pipe 3 in cubic meters per second. And the elevation of reservoir C. Okay. Okay. So how do you solve this problem? So this time ang given ay yung elevations ng reservoirs A and B, yung highest reservoir and middle reservoir natin. And then given din yung pressure dun sa my junction, which is 4950 kilopascals. Okay, so we are to solve for the discharge in pipe 3 and the elevation of reservoir C. So again, gawin natin is we do not know ano kung yung discharge natin is ang critical kasi is the middle reservoir. So obviously the highest reservoir, the discharge sa may pipe 1 would always go downwards, no? Unless may pump dyan na pumupunta doon, nagkakos ng flow mataas. But since wala namang pump doon, then by gravity the discharge in pipe 1 is going downwards. And sa may reservoir B, do not know. Again, we do not know whether reservoir C has higher elevation compared to reservoir B. Pwedeng yung C ang basta yung middle reservoir natin ay lagging. It's middle because of in terms of its elevation. Ano? Hindi yung pagkaka-go-hit niya doon, pagkaka-drawing niya doon sa figure, but because of its elevation. It's middle in terms of its elevation. Okay, so yung lowest reservoir, of course, may pag ganun yung flow sa lowest. Ang hindi natin alam ay yung flow sa may pipe 2, kung downwards ba siya or upwards. And the determining factor, of course, is the elevation of the imaginary piezometer at the junction. So magkakaroon tayo ng imaginary piezometer sa may junction. Again, if the piezometric reading, so if the piezometric reading here is higher than the middle reservoir, that means ang discharge natin is pataas. Okay? Kung lower naman yung reading natin, nandito siya, ibig sabihin yung discharge natin ay pababa or towards the junction. That's it. So, we need to know the reading at the junction. Kailangan natin malaman yung reading sa may junction. So, yung elevation ng reservoir ay 933. Reservoir B is 844. Okay, and C is unknown. Okay. The elevation of the junction dito sa may kung saan sila nagtungtugtong ay nasa na yun? Where is it? Ayun. Junction P. That is 366 meters. So yung elevation ng J natin dito, elevation of the junction J is simply equal to 366 meters plus ito, let's say that is H. That's H. So how do you solve for H? No. How do we solve for H? Given naman yung um, pressure reading sa may junction. So we can convert that to an equivalent pressure head in water. Then that would be the reading of the uh, the elevation or yung piezometer natin. Yan yung reading sa piezometer natin. So let's solve for H then. So H is equal to P over gamma. You can remember how to convert pressure to pressure head. We simply divide the pressure divide it by the unit weight of the liquid. In this case, we have water. So water. So we have 4950 kilopascals divided by the unit weight of water, 9.81 kilonewtons per cubic meter, and that would give us piezometric reading that is equivalent to 504. That's very high. 0.59 meters. Napakataas na pa. You will need very high piezometer. No? Okay, so that the elevation of the junction is equivalent to 366 ito. Plus the reading or the pressure head, this 504.59 meters. So the elevation of the junction then is equivalent to 870. 870.59 meters. Yung elevation ng junction natin, ito. Which means that it is higher than reservoir, the middle reservoir B natin, which means that Q2 is going towards reservoir B. Okay, so 870 ito, and this is 844. So obviously Q2 is going towards reservoir B. So if that is the case, nandito yung ating piezometric reading, and we will be arriving at this figure. So i-drawing na lang natin. Okay. Figure natin, okay? So, mas mataas yung elevation ng junction natin compared sa middle reservoir. So, our equation for discharge then is equal, Q1 is equal to Q2 plus Q3. Okay. Q1 is equal to Q2 plus Q3. Okay. Ayun yung equation ng discharge natin or full equation of flow. So next is, so ang goal natin is to solve for the discharge in pipe 3 and the elevation of reservoir C. So again, how do we solve the discharge? How do you solve the elevation of reservoir C? Let's try to formulate an equation that would give us an idea how to solve for the elevation of reservoir C. So the elevation of reservoir C is simply from the figure, in figure natin. So take note again that the difference in elevations between the elevation of the junction and the elevations of the reservoirs are actually the head losses. Yun yung head losses natin. So yung difference in elevation between yung junction and reservoir A, that is HF1, HF2, ito naman difference in elevation ng B and junction. Difference in elevation between C and junction is HF3. So kailangan natin ng elevation ng junction para ma-solve yung elevation ng C. Elevation of the junction minus head loss ng pipe 3. So kailangan natin yung head loss sa pipe 3, which again, which would require us to solve for the discharge in pipe 3. So kailangan din And to solve for the discharge in pipe 3, we need to solve for the discharge in pipe 2 and the discharge in pipe 1. Okay? So can we actually solve those quantities or values? So, ano bang kailangan natin para ma-solve yung discharge? Let's start with pipe 1. Anong kailangan para ma-solve yung discharge sa pipe 1? So para malaman yung discharge sa pipe 1, we need to know the value of HF1. What is HF1? The difference in elevation between elevation of A and elevation of junction. So HF1 is simply equal to 933. Let's say, lagyan natin ng explanation. Hindi, wag na. So 933 meters minus the elevation ng junction, that is, I forgot, what was it? 870. 0.59 meters. So HF1 is equal to, isang space mamaya, 62.41 meters. Now if HF1 is equal to this, then we can solve for the discharge in pipe 1. Next is we can also solve for, ang kailangan natin para ma-solve yung Q2 ay kailangan nating ma-solve yung HF2. Again, similarly, tulad dito sa pagkuha ng HF1. HF2 is just the difference in elevation between the elevation of the junction and elevation of Reservoir B. So elevation ng, so we have 870.59 meters minus 844 meters. So HF2 is equal to 26.59 meters. Okay, then we can now solve for the discharge. So let's solve for discharge now. So HF1, which is equal to 62.41 meters, is equal to 0.0826. F1 is 0.02 times 1,500 na length ng pipe 1 times Q1 squared all over D1 raised to 5. What is D1? That is 0.6 raised to 5. So we have one unknown in the equation, which is Q1. So Q1 is 1.4 cubic meters per second. And Q2 can also be solved using yung HF2 natin. So HF2 is equal to 26.59 meters. That is equivalent to 0.0826 F 0.025. The length is 1,000. Q2 squared all over D2 raised to 5. D2 is 0.45 raised to 5. Is it? Yeah, I think so. Q2 then is equal to 0.49 cubic meters per second. Okay? Which means that using this equation, we can now solve for Q3. That's simply equal to Q1 minus Q2. Okay. So Q3 is equal to Q1. It's 1.4 cubic meters per second minus 0.49 cubic meters per second, and that would give us a value equivalent to 0.91 cubic meters per second. So this would be Q3. Okay, this would be our Q3. I think that's one of the unknowns. So Q3, 0.91 cubic meters per second. Yan yung mga, one of the required para dun sa problem natin. So Q3 is 0.91 cubic meters per second. Now we need Q3 to solve for HF3. Let's turn the page around. If you can hear the storm right now. So again, going back to our equation to solve for, so we're done with Q3. We are now to solve for the elevation of Reservoir C, which is equal to the elevation of the junction minus HF3. So what we need now is the value of HF3, which can be solved using, which can be solved if we already know the value of Q3. So HF3 is equal to 0.0826 F, 0.018, 900 yung length ng part 3. Then we have a discharge of 0.91 squared all over 0.5 raised to 5. So we have HF3 equivalent to 35.46 meters. So that's HF3. Now we can solve for the elevation of Reservoir C. That is 870.59 meters minus 35.46 meters. So elevation of Reservoir C is 835.13 meters. Obviously, the Reservoir C is the lowest in terms of elevation. No? The lowest reservoir. So that would be the elevation of Reservoir C. C. Okay. So we have one last problem left to solve, and that would be mahaba palang solution ng last problem. So we will just solve it, present it in a separate video.